Alrighty, so topic 3 is about the graphs of exponential functions. So we're going to start with this example about Matthew. His teacher has asked him to help demonstrate exponential functions. She has asked him to stand 24 feet away and then repeatedly walk half of the distance to the door. Fill in the table below to show this relationship. So, again, he's starting 20 feet away, then he walks halfway to the door, so he's at 12 feet away, then 6 feet away. So let's continue. He would be 3 feet away, then 1.5 feet away, continue to cut this in half, so 0.75, continue to cut it in half, so that would be 0.375, continue to cut it in half would be a smaller number, 0.1625, I think. I need my calculator, etc. is what I'm going to write right here, because I don't know what that is. So, let's go ahead and sketch, we'll come back to it. Let's go ahead and sketch our points in the graph. So he's going to after about halfway, and then halfway. Okay, so we're getting into the decimals. So question number 1 says, when will Matthew hit the door? In other words, when will his distance to the door be 0? Well, if we think about this, if his teacher is constantly saying walk halfway to the door, and she's never saying, hey, okay, go ahead and touch the door, then he the door, right? Over here, I went and grabbed my calculator. Oh, see, I totally did this wrong. Oh, no, I didn't. Oh, yeah, here we go. This should actually be 0.1875. I can't do that kind of math in my head. We divide that by 2, we'll be at 0.09375. We divide by 2 again, we're at 0.046, something. So we're getting smaller and smaller, but we're actually never going to hit 0. So when we hit the door, never. Okay, he's never going to touch the door because he's always going halfway there, right? So this picture shows that. But you technically hit the x-axis right here, okay? So number 3 says write an equation. So just real quickly, again, y equals a times b to the x. A is the initial value, so in this case it's 24 times b is that rate of change. In this case it's the common ratio we're multiplying by, so it'd be 1/2 to the x. So what we just described is something called an asymptote. P in it. It's pronounced asymptote, almost like. So what an asymptote is an imaginary line that a function approaches but never touches. Okay, so for our exponentials, the asymptote is the x-axis. It's this dotted line. It's never going to touch the x-axis. It's going to get closer and closer to actually cross it. Okay, really quickly, this is a HOI, the horizontal line. It's a HOI. So the equation would be y equals, and then 0, because it goes through the origin, right? Y equals 0. The asymptote for these exponentials is y equals 0. This right here is the y-intercept, just as a reminder. Aware of and the asymptote. Okay. So again, domain and range. We've done what we've had. Domain, left to right. Arrow should go forever left and right. So numbers or that fancy R. Okay. Range, however, is not all real numbers because it doesn't go forever up and forever down. We just said it's never going to cross this asymptote, right? So it does go forever up, but it stops at the asymptote. So we could just say y with 0. It's not equal to y is greater than 0. It's never going to go below it. Okay? So let's practice a little bit. Number 4. We're just going to write the domain and range of each one as well as the asymptote for each one. So for the first one, left and right, real numbers. The domain of the second one, all real numbers. Range of the third one, or just domain, it's all real numbers all the way, right? Even these two that are down here, it's still going to go forever to the left and forever to the right. Okay. Now the range for this first one is above the x-axis, greater than 0. Okay. The range of the second one, here's the asymptote, still y is greater than 0. To get to these last two, they've actually been flipped down. They're underneath the y-axis. So these are actually y is less than 0 because they're below y-axis. okay? Below the x-axis, sorry. So now asymptote for all of it's that whole way, y equals 0, all the way across, because for our class, asymptote is always going to be the x-axis. That changes as you get into Algebra 2 and you learn how to shift these functions up and down. But for our class, it's just going to be the x-axis. So, if you have multiple colors, like colored pencils, you might want to grab those. We're going to do some graphing and comparing of graphs at this point. If you don't, that's okay. So number 5 says complete the table of values for f of x equals 2 to the x and then graph them on the graph. This process column is where you're supposed to put the x value to the -3, which we know that 3. Same, we plug in be 1/4. Do this for all of them. I'm just going to go plug them in mentally, just for the numbers. This is where you would write the coordinate itself, -3, 1/8, -2, 1/4, -1, 1/2, etc. Really, x graph. 1/8 would be just barely off the x-axis. It's hard to do with my big old marker in this itty-bitty graph, but just trust me. 0 is at 1. There we go. So it should look something like that. Okay? So the graph gets steeper as it goes to the right and then it flat. If my pen makes it look like it does. Okay? So then let's do it again, but this time we're doing the x. So this would, right? If I flip it, and then, etc., right? So, got these numbers, so those are our points. And here's y. So -3. So this one looks like this, and again, it does not cross exactly. So the bottom box is what is the only difference between the two. What I say difference, there's but they've got 1 and 1/2, 1/4, etc. They're both exponential. They both cross similarities here, but the main difference is that one is increasing and is decreasing. So this first one, read it from left to right. So starting over here on the left-hand side, if I read it to the right, it's going to increase as I read. It's going to go up. This one, starting on the left-hand side of the graph, I'm going to read it and it's going to go down. So it's decreasing. So looking at B right here. If B is between 0 and 1, if B is between 0 and 1, it's going to go down. If it's greater than 1, like it was on the last problem, 2, that means it's increasing. It should be going up the page. Okay? Now, before I move on, I do want to go back to number 4 and just kind of really quickly go over whether or not these are increasing or decreasing. The first graph on number 4, if I read from left to right, my pen goes up. That's increasing. The second graph, left to right, my pen goes down. So here's where things get tricky. This third graph, again, reading from left to right, goes up the page. This is increasing. A lot of people get confused on this one because it's below the x-axis, but this is going up when I read it from left to right. Okay, this last one though, left to right goes down, so this is actually decreasing. Okay, so going back to this, again, here's orange color, so we're going to graph, oh no we're not, just kidding, we're only going to graph one thing on here. But let's go ahead and fill out this box before we graph it. So it says the value of b. Looking over here at my equation, my b is 2. My a is -2. Well, based on the rule that I just said, this is above 1, so it should be increasing. The y-intercept is the same as a, so -2. The asymptote we've said is the same all the time, so y equals 0. The domain we've said is the same all the time, so all real numbers. Range, we have a little bit between above or below the x-axis, so we'll hold off on that one. Let's go ahead and graph this one. So let's plug in, for example, 0. Let's get our y-intercept. If I plug in 0 here, I'm going to get -2. It's down here, which is interesting, right? Okay, let's plug in a 1. Well, what's -2 times 2? That'd be -4. Okay, if I plug in a 2, that's -2 times 4, that'd be -8 down here. I can kind of see what the pattern is here. If I plug in a -1 right here, that'd be -2 times 1 over 2, -1. You can see what's happening. This is what the graph looks like. Okay, so we said that this is supposed to be increasing. Well, is it increasing? No, this is actually going down the page. So what do you notice about B? Do the rules still apply? No, the rules do not apply. And just to fill this in, the range is less than 0. So what transformation has occurred? Well, think back to quadratics. Our A right here is -2. Think what that meant that it had been reflected the x-axis, right? It means the same thing here. And if that's the case, well, then the rules, of course, would be opposite, because this initially was like this, right, and increasing, but we have reflected it down, which made it decrease. Okay, so you have to watch out for that A being a negative, because that does different things to your graph and kind of messes up the rules. All of that to say, I'm going to come back to that. Let's do this. All that to say, if I were to give the problem, I'd say, okay, we've got 1/2 times 3/4 to the x with a negative, and we've got +2 times 3/8 to the x, and we've got -4/3 times 9/5 x. If I go through all these and say, is this increasing or decreasing? Is this increasing or decreasing? Is this increasing or decreasing? Do not sit there and try to remember the rule. Don't worry about the rule. Just put it in your calculator and look at it and see. We're not spending a lot of time on exponentials here in Algebra 1 because you're going to spend more time with them in Algebra 2. We're just trying to expose you a little bit, just like you got exposed to linear functions when you were in 6th and 7th grade. So don't worry about exponentials too much right now. All the rules. Just use your calculator to really see what they look like and determine if they're increasing or decreasing. Don't stress over these rules. Okay. However, we can use these rules to kind of estimate some things. So looking at the graph on the right, is this increasing or decreasing? Well, it's decreasing. It's going down. So number 6 is, what is the most value of B? And we know it's the y-intercept. Our graph, it's looking at my options, 0.05, no, we're close to that. 0.45, no, 2, no. 19.7. Even if I thought it was 20, well, 19.7 is pretty stinking close, so that's the most. Number 7, which is fine, the most reasonable answer for B, and that's the at which something is changing. Well, if we've already said this is decreasing, we need number would cause this to decrease. If I multiply something by 5 over and over and over, it's going to get bigger, not smaller, right? If I multiply something by 0.45, well, that's close to like a half. Is half each time? 20-ish, 10-ish, 5-ish? Well, yeah, I think it might be good. C, if I multiply something by 3 over and over, it's going to decrease. No. D, close to 20 again. If I multiply something by 20, not going to decrease. Our answer there is B. So even though I don't know the exact number at which it's decreasing, I can just reason through it and think, well, 0.45 is what's going to make this go down. The other ones would make it increase. Okay. I think that's actually it. So again, exact science at this point in your mathematics career, as far as calculating numbers and things like that, but you just overall reasoning. Your test and your TEKS are going to be multiple choice, so at least parts of it will be, to answer a lot of these questions, and using what you know about A and what A stands for, and what B stands for. Alrighty, so if you have any questions, ask.